So I want to go over a quick example of how we find Nash equilibrium using a payoff matrix. So in this game, we're going to talk about a game between American Airlines and United Airlines where they're supplying air service between Chicago and St. Louis. The strategies to do these two carriers are to increase their advertising by $1,000 or not increase their advertising. So each company has two different strategies. Assume that all payoffs are known to all parties. And so a payoff matrix is just a table that describes all the possible combinations of payoffs for all the different combinations of strategies within a game. So this would be the payoff matrix for for this game. And I want to highlight how we solve this payoff matrix. So the key to any game theory is to put yourself in the other person's shoes. So for United, what they want to do is they want to put themselves in American's shoes. And they say, okay, if American is going to raise their spending, what do I want to do? What's my best response given what my opponent does? So if my opponent, American, raises their spending, I can either raise my spending as well and get $5,500 or not raise my spending and I will get $20 or $2,000. So if American decides to not raise, then my options are raise spending and make $8,000 or not raise and make $6,000. So you can see in either case, no matter what American does, United's always going to have a dominant strategy to raise its spending. So if American raises its spending, United is better off by raising. $5,500 is greater than $2,000. Or if American doesn't raise, United is still going to want to raise because $8,000 is bigger than $6,000. Okay, now to find an equilibrium, we need to find one where both of them are doing their best response. So in this case, I would underline this and I would underline that if I had a sheet of paper. Okay, now let's do it for the other company. So now American is going to say, well, what if United raises their spending? And if United raises their spending, well, then American can raise and get $5,500 or not raise and get $2,000. So they would raise their spending. And if United was going to not raise, then American would choose between raise its spending and get $8,000 or not raise and get $6,000. So again, $8,000 is bigger than $6,000, and so American also has a dominant strategy to raise their spending. So what's going to happen is both companies are going to raise their spending. They're both going to play their dominant strategy, and the resulting payoffs are going to be $5,500 for each firm. Now notice if they had each not raised their spending, they would have got a better payoff. And this is what's called the prisoner's dilemma. So a Nash equilibrium is any combination of strategies where each player's strategy is his best choice given the other player's strategy. So I want to go back and remember that raising was United's best option given if their other company was going to raise, and raising was American's best option if United was going to raise. And so this is the only cell here where both companies are playing a best response. Okay, now let's change the payoffs here. So this is the same two players, same strategies, but different payoffs. So now this is a non-symmetric game where the last one was symmetric. So now let's do this again. If American is going to raise spending, so to decide what United's best option is, we have to decide what we do if our opponent raised spending. So now if American's going to raise, United says, well, if I raise and they raise, I'll get $3,000. But if I don't raise while they raise, I'll get $4,000. So in this case, if United knew American was going to raise its spending, they would want to not raise. And alternatively, if they knew that American was not going to raise their spending, they could raise and get $8,000 or not raise and get $5,000. So in this case, $8,000 is bigger than $5,000. So if American doesn't raise, United would raise. And if American does raise, United would not raise. So as you can see here, United no longer has a dominant strategy. They no longer raise spending regardless. In this case, if American's going to raise, they won't. And if American doesn't, they will. Now let's solve this for the other player, for American. So they're going to think, okay, what if United raises their spending? Well, I can get $4,000 if I raise, or I can get $3,000 if I don't raise. So I will raise and get $4,000. And what if United decides not to raise? Well, then American says, well, if we raise our spending, we'll get $5,000, and if we don't, we'll only get $2,000. So in this case, we will raise. Notice that American has a dominant strategy to raise their spending. No matter what United does, It's always better for American to raise their spending than not raise their spending. And so what's really critical here is to know that since United knows American has a dominant strategy, United also knows that American will raise their spending no matter what. And so since American is going to raise their spending no matter what, United Airlines is going to choose not raise. And so this cell here is going to be the equilibrium. Okay, American is going to raise no matter what because that's their best response. And knowing that American is going to raise, United will choose their best response to American raising their spending, and that is to not raise spending for United. And so again, this bottom left cell here is going to be the Nash equilibrium of this game. United anticipates and does not raise. Okay, I hope this helps you out in solving these games. If not, make sure you look at the other examples that I post in the related media section.